Today we're taking a lesson on arc length and sector area, and this was done on Thursday, January 19th. So the first thing that we talked about today in class was that we have the formula for the area of a circle is pi r squared, and that the formula for the circumference of a circle is pi times diameter, or c is equal to 2 pi r if I'm given radius, because it takes 2 radii to make 1 diameter. And also we talked about a circle being 360 degrees, is 360 degrees. Now, what we also talked about, this tick mark right here, these two tick marks mean that they're congruent to each other, and then there's one on each, so I know that arc EAH is congruent to arc FG because of the tick marks. We also talked about that this is an arc. An arc definition is it's part of the circumference. So EH is part of arc EH is part of the circumference. We also talked about that line segment HG is the diameter, and so the diameter splits the circle into 2 equal parts. So if the whole circle is 360 degrees, then half of the circle, so this arc, so arc HG, is going to be 180 degrees. And that would also mean that the other side, arc HFG, would be 180 degrees also. So here we go, we start and we are given with the measure. This means measure, the M, and if I'm asking for the measure, I'm looking for a degree. Just like when I'm asking for the measure of an angle, I'm looking for a degree. It says the measure of EF is 80 degrees, arc EF. So that minor arc there, it's a minor arc because it's less than 180 degrees, is 80 degrees. Now, we talked a second ago, HFG, so going this way around, is a semicircle, and the measure of that is 180 degrees. And the reason I know that is HG, line segment HG, is the diameter, so it splits it in half. The next thing it asks you, what is the measure of arc EH? So you have to do some calculations here. Well, I know this whole measure going from H to G is 180 degrees, and I know this part right here is 80 degrees. So I can find out what's left over, and what's left over is 180 minus 80, so it's 100. And then I have to take that 100 and divide it by 2 because there's 2 equal parts of the circle. So then 100 divided by 2 is 50 degrees. Now, moving on along to EG. So here I want to know, so this is 50 degrees, and if this is 50, knowing it's congruent to this arc over here, it's 50 degrees, and then they wanted you to find the measure of arc EG. So I would have to add 80 plus 50, and it's equal to 130 degrees. The next measure asks you to find the measure of arc FGH. So here I have to add 50 and 180, and when I do that, it's 230 degrees. So that gives you an idea of how to work with the congruent marks and the measures of the arcs. Now, moving on along, we have talked about the measure of an arc, and an arc measure is in degrees. And then we talked a little bit about an arc length. So the length of an arc has to do with the distance of the arc around the circle. Now, the measure of the arc, because a circle is always 360 degrees, it doesn't matter what the circumference is. So if it's divided into equal parts, then like 10 equal parts, each of the arcs will always be 36 degrees. But arc length depends on how big the circle is. So as the radius gets larger, your circumference gets larger. So the arc length, so each section will be a little bit longer in distance. So LM, I'm looking here and I'm looking for the measure of arc LM. And here you can see that my circle is divided into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So I know the whole circle is 360 degrees, and I'm going to divide that into 8 equal parts, and so each part, or each arc measure, is going to be 45 degrees. So We're going to save arc length for a second. The next step is SP. So I want to go from here to here. And if you notice, there are 3 arc segments that have a measure, or arc lengths that have a measure of 45 degrees each. So I just take 45 times 3, and it's 135 degrees. So the measure of SP is 135 degrees. Now, the arc length depends on what the circumference of the circle is. So the first step that I need to do is I need to find the circumference of the circle to the left. So circumference is equal to 2 pi r. So in this situation, I plug in 10 for r, so the circumference is 20 pi. And when I multiply that out in my calculator, the circumference is equal to 62.83, and that's in inches. So I know that that's the total length around the entire circle, but I don't want the total length around the entire circle. I want part of that length around the circle, and I want an 1/8 of that. So I'm going to say 62.83, and I'm going to divide it by 8, and so the arc length of LM is 7.85 inches. Now, we kind of do the same process here. I know that each little section has an arc length of 7.85, and there are 3 of those arc lengths that make up SP, so I multiply it by 3, and I find that my arc length is 23.55 inches for arc SP. So that deals with part of the circumference, or arc. An arc is part of the circumference. So arc, part of the circumference. That's our definition. Now, so we've talked about part of the circumference, and now we are going to talk about part of the area. And that is a sector. So the sector is part of an area. And it's kind of like a piece of a pie. If you think of the circle as being a pie, I'm talking about like the area of that piece of the pie that's formed by usually an angle, so POQ. So I'm talking about this area right here. So I want that part of the whole area of the circle. So the first thing I'm going to do is I'm going to plug in the area of the circle into my formula. It tells me the diameter is 3, so I have to half that, and then I need to square it, so it's 9 pi. And then 28.26 inches squared is the area of my entire circle. But I don't want the entire circle. I just want this part of it. And it's broken into equal parts. Again, it's indicated by the congruency marks. And it's 1, 2, 3, 4, 5, 6. 6 equal parts. So the area of that sector is 28.26 divided by 6. And so that area is 4.71 inches squared. Now, going to the second page, we're talking, it wanted you to calculate the circumference in the area of the given circle. The radius is 4.2 inches, so all I do is I plug it into the formula, and the circumference is equal to 2 pi times 4.2, and that's equal to 26.38 inches. And the area is equal to pi r squared, or pi times 4.2 squared, which is 55.39 inches squared. So the next step it wanted me to find is the length of AB. And you can tell from my circle that it is divided into 1, 2, 3, 4, 5 equal parts. So I want the length, so I'm dealing with part of the circumference. So I know my whole circumference is 26.38, and it's divided into 5 equal parts. And when I divide it by 5, then it's 5.28 inches. Now, if I asked you the measure of arc AB, now it didn't ask you this, but I want the measure of arc AB, I would find 360 divided by 5, and it's 72 degrees. So length you will have in a unit measure, or a unit, and then the measure I'm going to find in a degree. Now, the next step is it wanted you to find the sector area of ACB. So again, I just want one piece of my pie, or one part of the area. So my total area is 55.39, and there are 5 equal parts, and I just want to know the area of one of those parts, so it's just 11.08. So that's kind of the situation that we have going when they're broken into equal parts. I'm going to tape another video that we're going to have to use some formulas whenever in the situation of number 5 it's not broken into equal parts.